2.2 Intercepts and Symmetry. So intercepts are very, 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 very important in algebra and calculus for multiple reasons, and we'll talk about that as the semester continues. So intercepts, we're going to talk about them at least once a week because they're that important, and we'll learn so much about them. And then we're going to talk about symmetry. So symmetry is important because symmetry, if you think about it, it's like, when you fold a piece of paper over and it goes on top of each other, or you put your hands on top of each other, you go ahead and do it, and you see how they go on top of each other perfectly. It's because we're symmetrical, and things in nature are symmetrical. That's why we talk about symmetry, because a lot of things naturally are symmetrical. All right. Before we get ahead of ourselves, let's talk about intercepts. So let's find intercepts. To find intercepts of an equation, and you see I'm not being specific, if it's an equation, this is how you're going to find your intercepts. To find the x-intercept, you make y equals 0, and you're going to solve. Your point will be number and 0. If you want to find the y-intercept, you make x equals 0, you solve, then you have 0 and that number. So let's find the intercept or intercepts of the graph y equals x squared minus 4. So it doesn't matter what it looks like, we just find our intercept. So we have two of them. We have x-intercept, and how we find the x-intercept is making y equals 0. And then we also have the y-intercept, and we solve that by making x equals 0. So do you notice the one we're trying to find? So we're trying to find the y-intercept. The opposite of that is x. That's why we make x equals 0. The x-intercept, we make y equals 0 because that's the opposite. The opposite of x is y. That's why we make it 0. So let's replace it in the original problem. So we're going to replace y, and then we'll replace x. So we'll have 0 equals x squared minus 4. Now there's two ways that we can solve this. We can factor, or we can add 4. I would factor. I would highly suggest, if you're going on to calculus, that you factor. But if not, if you're cool with it, you can go ahead and just add 4. You're not wrong by doing that. You are still 100% correct. So we have 4 equals x squared, and we get rid of this squared by square rooting it. So we get 2 equals x. But is it just regular 2? No, it's positive negative 2. Because when we square root something, it's a positive version and a negative version. Now let's find our y-intercept. So for our y-intercept, we're going to make x equals 0. So y equals x squared minus 4. Do you notice when I say x, I put parentheses? Let's get into that habit. So we have y equals 0 squared is 0, so negative 4. And those are our intercepts. So our intercepts are negative 2, 0, 2, 0, and 0, negative 4. So those are all our intercepts. And again, we'll talk way more about why that's super duper important later on in the semester. Right now, let's just practice finding them. All right, now we're going to move on to symmetry. So we have 3 types of symmetry. A graph is said to be symmetric with respect to the x-axis if, for every point xy on the graph, the point x negative y is also on the graph. So let's kind of make a little bit more sense of that. So if I had a point right here, and let's just say it's 4, 2. Here, I'll put that right here. Let's say it's 4, 2. Then this point right here, it would be 4, negative 2. Sorry, my pen messed up. So it's said to be symmetric to the x-axis. What do you notice that's opposite? The y's. Math makes sense sometimes. Most of the time it does. If we're talking about x-axis symmetry, the opposite, which is y, will be different. So that's why the 2 changes to negative 2. And that's how it would become symmetrical. So that's what it means for every point xy, you also have x negative y. So you have opposite y. You also have a graph is said to be symmetric with respect to the y-axis for every point xy on the graph. The point negative xy is also on the graph. So you notice how it says it's symmetrical to the y-axis? Let's see what they're telling us to switch. So it says for every point xy on the graph, the point negative xy is on the graph. So the opposite of y is x. That's why the x is being switched. So if we had a point right here at, let's say, -4, 3, that means this point right here would be 4, 3. You notice the x's is the only thing that changed. Also, if you fold it over the y-axis, so if you fold it over, it'll go on top of each other. Same thing on the x-axis. If you fold it over the x-axis, it goes on top of each other. X-axis is like when you fold the paper like a hot dog or a taco, and y-axis is when you fold it like a burger. That's how you can look at it. The last type of symmetry you have is origin. So a graph is said to be symmetric with respect to the origin if for every point xy on the graph, the point -x, -y is also on the graph. So there's really no special way to remember this. It's just you're going to switch both because origin is diagonal. So diagonal, you're switching both. So this is if you fold it over diagonally like this, that they go on top of each other. So if we had the point here, and let's say that's -2, -4, that means this point right here would be 2, 4. You switch both. All right, you notice how we're saying that you switch both. You switch y, you switch x. That's looking at it graphically. But guess what? You treat it the same exact way if you want to test for symmetry using algebra. So to test the graph of an equation for symmetry with respect to the x-axis, you replace y by -y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. And it's the same all the way down. So if you want to test for y-axis, you replace x by -x. And if you want to test the origin, you switch both. You have to test all three. You have to test all three. No matter what, test all three. So let's do that. I'm going to start off on a bit of an easier one because of the fraction. I'll have to switch that around for next semester. So let's start off on example 3. So let's test this, test y equals x cubed for symmetry. So sometimes it's easier to test it via equations, which is algebraically, than graph it. Because we don't know how to graph x cubed. We don't. But we know how to work with algebra. So let's test all three. The first one we get to test is x-axis. So the opposite of x is y. So opposite of x is y. That means you're going to switch every y in the given equation to -y. So the given equation is y equals x cubed. So every y inside of that is going to be switched to -y. So we have y, we're going to make that -y, equals x cubed. And from there, you're going to solve it. What I mean by solve it is that we're not allowed to have -y. That doesn't exist. So we need to solve it, and by doing so, we are going to multiply by -1 to get rid of the negative. So we have y equals -x cubed. Now, if we pair it and try and match it to the given equation, is it identical? It's not. The given equation is y equals x cubed. The equation that we came out with is y equals -x cubed. It's not the same, so it's not symmetrical with respect to the x-axis. We move on. So when you test something for symmetry, when you test something, does it always work out? No, not always, right? That's what we're doing. We're seeing, does it work? Because if testing it works, that means it's true. It works. We tested it. It is symmetric to whatever axis. But if it's not the same, it didn't work out. Let's move on to the y-axis. So what's the opposite letter of y in math? It's going to be x. So what we're going to do is we're going to switch every x in the given equation to negative x. So in the given equation, y equals x cubed, we're going to switch that x to negative. So we have y equals x cubed, and in that x, we're putting negative x. So negative x times negative x times negative x is negative x cubed. Now, is that the same as the original? It is not. So it is not symmetric to the y-axis either. Now we switch, or we test the origin. Origin, there's no special way to think about it. It's just both. So you do both. So we're going to combine the two steps that we did for x-axis and y-axis. So we have negative y equals x cubed, and that's where we're going to put negative x. So do you notice how we put the green and the purple together? That's why. Next semester I'm going to do it where the two colors equal the blue. That'll make more sense. Anyways, so let's simplify this. We know that it's negative y equals negative x cubed, because negative x times negative x times negative x is negative x cubed. And then we need to get rid of this negative y, so we multiply by negative 1. And all that does is just switch the signs around. So we have y equals x cubed. Now, is that the same as the original one? It totally is. So we can say that this is symmetrical to the origin. So how we would actually write that is symmetric with respect to the origin. That right there just means with. It just means with. That's all. That W with a slash means with. And I do have to sing respect every time to spell respect. Unlike Andy, who can't. From Parks and Rec. You know what I'm talking about. Alright, so no matter what, we have to test all three. And you can have multiple. You can have none. You can have all three be symmetric. It doesn't matter. So you can have a multitude of types of answers. So you can have x-axis, y-axis, origin, or x-y-axis, y-axis, origin, or none of them. All right, now let's go back to example 2. Let's test y equals 4x squared over x squared plus 1 for symmetry. All right. So no matter what, we have to test all three. So let's start off with x-axis. So for x-axis, we're going to switch y to negative y. That's how we would abbreviate how we said that instead of writing that whole sentence for it. So in the given equation, we're going to switch y to negative y. So negative y equals 4x squared over x squared plus 1. Now, why are we allowed to just make it negative y? Because when you test something, you're making it into something to see if it works. Think about it. So when you're testing something, you're putting things in to see, does it work? So are we allowed to have that negative y? We are not. So let's multiply by negative 1. All we do is just move it to the other side. We have y equals negative 4x squared, x squared plus 1. The negative can go anywhere. Remember that so negative 1 over 2 is the same thing as 1 over negative 2, and that's the same thing as negative 1/2. Then the negative can go anywhere, it doesn't matter. It just means you have a negative fraction. So put it where you think it should go. And in this case, it doesn't really matter. I just throw it in the middle. So we put it in the middle. So is this the same as the given equation? It's not. The equation we came out with has a negative. The given equation does not. So we say it is not. Now let's move on to the y-axis. So what's the opposite variable to y? It's x. I hope you know when I make my videos and I'm saying a question, I'm totally picturing like it's Dora or Blue's Clues TV show. You know, like I'm asking like, what's the opposite of y? And then you scream out X. I hope you know that's what I'm feeling. I hope you're doing it. If not, let's start doing it. I know it sounds stupid, but it actually works. It'll work. And it's fun. Why not have fun with it? Have fun learning math as much as you can. All right, back to math. I told you these videos are just like I'm in class. You just don't get to see my beautiful face. All right, so let's switch our x to negative x. So in the given equation, every single x is going to become negative x. So we have y equals 4x squared over x squared plus 1. You notice every time I say x, I put parentheses. Then I go back and put my negative x. Get into that habit. It will make your life a little bit easier when we go through the semester and then the rest of your math classes that you have to do. So let's simplify this. What's negative x squared? So negative x times negative x is going to be positive x squared. So we have 4x squared over x squared plus 1. Now let's compare it. Is it the same as the original? It totally is. It is. So let's say that, yes, it is. Sweet. It matches. Move on. Remember, we have to test all three. So let's test origin. You might pick up on patterns. There are patterns. You're not crazy. So if you start to see things and you're like, I kind of think I know what's going to happen, you're not crazy. There are patterns here. Remember that math is just the way to express patterns in which we live. So look for the patterns. Trust me, they're there. You're not going crazy. So for origin, we switch both. You may or may not be able to tell right now that it's not going to work. And if you can't tell, it's okay. And if you can't see the patterns ever, guess what? It's okay. Sometimes we don't see everything that everyone else does. We're all very, very different in that sense. So let's go ahead and mush both of the steps together. So we'll have negative y equals 4x squared over x squared plus 1. And in that little parentheses part, we're going to put our negative x. So you notice how we just mushed both steps together. You can see that we put the green and the purple in. So let's go ahead and simplify this. We have negative y equals positive 4x squared over x squared plus 1. And then we're not allowed to have this negative y, so we get rid of it. Do you notice that we kind of already did this already? If you can't, I'm going to point it out to you. See how we did that already? It's the same step. So you don't have to keep doing it. You can just stop there and be like, it doesn't work. But let's keep going. Let's keep going for the sake of the notes. So we'll have y equals negative 4x squared over x squared plus 1. Remember, the negative can go anywhere, either top, middle, or bottom. It only goes to one spot of the fraction, either top, middle, or bottom, and you decide where it should go. So it did not work out. The only thing it's symmetric to is the y-axis, so I'll put that up here. You're going to hear my dogs bark. So we say it's symmetric with respect to the y-axis. All right, next example. For the given equation, we're going to test for symmetry. Could you have guessed that's what we are going to do? So this is what I highly suggest. you pause this video and try it on your own. And then after you think you're done, go ahead and start it again and see if it matches. You gotta try these on your own. Alright, so hopefully you paused it, and now we're back, and let's try this on let's do this together. So we have to test all three. We have our x-axis. So for our x-axis, what are we gonna switch? What's the opposite of x? It is y. So we're gonna switch y with negative y. So we have 4x squared plus 9y squared equals 36. And in that parenthesis, we're going to put negative y. So what's negative y squared? It is positive y squared. So we'll have positive y squared equals 36. Let's compare it to the given equation. Is it the same? Totally is. Since it is the same, we just put a yes or a check mark. You don't have to write anything. I just put yes so I don't forget. Alright, now let's move on to the y-axis. So for y-axis, what's the opposite of y? It's x. So we're going to switch x with negative x. So we have 4x squared plus 9y squared equals 36. And in that place, we're going to put negative x. So what's negative x squared? That's negative x times negative x, which is positive. So we'll have 4x squared plus 9y squared equals 36. And it worked out. Whoa, let's see if they all work out. Let's go to origin. They do. They all work out. So our origin, we're going to do both. We're going to combine both steps. So we'll have 4x squared plus 9y squared equals 36. And this is where we're putting both steps into it. So we'll have our negative y's and negative x. So we have 4x squared plus 9y squared equals 36, and that works out. So it's symmetric to all of them. On the test, you can say symmetric to all three. That's fine. But we're technically supposed to say symmetric with respect to the x-axis, y-axis, and origin. But you can just say all three. What shape is that, you might ask yourself, hopefully? It's a circle. If you think of a circle that's on the origin, like if you draw a circle that circles like the origin of a coordinate plane, you can fold it however you want and it goes on top of each other. We actually talk about circles in 2.4 and we graph them and work with them. It's pretty cool. You'll like it, hopefully.